Okay, let's remind ourselves what we're actually trying to get accomplished in this extension. Why do we want to use these formulas that have variables and not specific numbers? Because again, we talked about it yesterday. Why we don't want to do that? Well, we want to show properties hold in all cases, not just specific examples. They hold. They are true for everything, not just little special cases, is what we're trying to get accomplished here. By the end of this, with any luck, you'll have all of the skills in place to be able to actually do so. We worked on a lot yesterday in terms of solving formulas with variables in them and placing shapes, and now we're going to put it all together here. So on the front side are the final three building blocks that we're going to use in order to actually try to attempt a coordinate proof here. So three things we're going to do a lot of, because a lot of properties say things about parallel or perpendicular lines. They say things about the lengths of segments, and they say things about whether things bisect each other. Those are things that are used a lot in, that come up a lot in like theorems or other kind of cool properties. So maybe if we have a good way to talk about them in general, then we'll be all right. So the first one says, determine if the given segments are parallel, perpendicular, or neither. Parallel, perpendicular, or neither. What idea or what formula do you think is going to be slow? This is a slope idea. Parallel means equal slope. Perpendicular. And neither would be just none of the above. It says else.
The air of the anything else.
Anything. Anything else. Anything else. So maybe I apply the slope formula to each of these. So in the interest of time, I'm going to do just the ones on the left side, and you can save the ones on the right for extra practice if you want, or you can ignore them. It's totally your call. Okay. So determine if they are parallel or not. So I'm going to find the first slope here. So the first slope is y2 minus y1 over x2 minus x1. And I simplify that to be b over a. Great. This doesn't really mean anything until I've compared it to the second one. And with any luck, they'll either be the same, be opposite reciprocals, or none of the above. So the second slope should be y2 minus y1 over x2 minus x1. Last I checked, b minus 0 is b, and 2a minus a is also a. Okay, so I've performed some calculation here, and then I'd like to say, then I draw a conclusion. Since these slopes are equal, the lines are parallel. Same formula, same slope. They're both parallel. Okay, if I want to show two segments are congruent, congruent is same length So what's my appropriate formula for find if they're the same length? The distance formula. So I apply the distance formula to the two potential segments and see if I get the same thing. The distance formula. How about we subtract the x's, square it, and subtract the y's. That's a squared plus minus b squared. And what's negative b times negative b? Same as a squared plus b squared. Okay, then I check, so that's the distance of the first one. How about the second distance? Well, that's the square root of about 0 minus a squared plus 0 minus b squared, which I think we see the and as we saw, as above, minus a times minus I is positive a squared, minus b times minus b is positive b squared. These two, while not pleasant looking, are identical. Since the distances are equal, the segments are congruent. Okay. If I want to show two segments bisect each other, what is that? What am I looking for, Darby? Slope and distance? I'd probably go with midpoint, actually. If I use the midpoint formula, what am I hoping to see if they bisect each other? If they bisect each other, that means they cut each other at the middle. So that means they should each have the same midpoint. I'm looking to see that their midpoints are the same. So I find the midpoint of each and decide, are they equal or not? Are they the same thing or not? Midpoint. So if I find the midpoint of my first segment, that's average the x's, 2a plus 3a over 2. Average the y's, b plus b over 2. That's 5a over 2, comma 2b over 2, which is 5 halves of a and b. 2 divided by 2 being 1.
Do you want us to keep it in fractions or do we move it to decimals?
I highly suggest leaving it as a fraction. Again, you're not really concerned about what the numbers are. You're concerned that they're the same. So it doesn't. I guess it doesn't. It's not a huge deal for like dividing by 2. But if you start dividing by like say 7, where there's 6 repeating decimals, you may not want to like have to deal with that. When you could just leave this, although it's not pleasant to look at for some of you, it doesn't matter that it's nice looking or not. It just matters that it's going to be the same as whatever else comes out. So I find the second midpoint, which is average the x's. So add them and divide by 2. Average the y's. Last I checked, negative 2a plus 7a is 5a's. And 0 plus 2b's is 2b's. And that looks eerily similar to the first one. They have the same midpoint, so they bisect each other. Maybe not pleasant, but whatever it is, it's the same. Okay. Okay, there's 3 more examples you can do on your own if you'd like. In the interest of time, we're going to look at one of the proofs on the back. Maybe even both. So on the back, I've got some guidelines for how to actually go about explaining yourself here. And note these are guidelines. These aren't like hard and fast rules that you have to do every time. There's not like a checklist. There's not like a box that you have to put something in. But you should be able to, a good coordinate proof should address these. So first of all, know what what the thing you're trying to plot is, and maybe know what the relevant formula is that you're going to use. So in the case of the first one, prove the diagonals of a square are perpendicular. So first I got a square, and what formula am I going to probably be working with? Trying to show something is perpendicular, that sounds a lot like slope to me. So maybe I place my shape on here in an appropriate manner and a convenient manner. Any of the ways that we placed squares in the homework last night will be fine. I'm leaning actually toward the one where the point's in the origin. You don't have to. You could do the one. You could do the placement with the vertices on the axes. But I think it makes the slope calculations just a tad on the inconvenient side. Just when you're trying to calculate for sure what the slopes are, it's a little more you can and it works fine, but I think it's a little more clear to see what the slopes are if we go this route. Darby.
If we're moving the diagonals, isn't it easy to make the midpoint of the diagonals the origin?
Again, you can, and it'll be fine. I want to show you how this came up, the calculation here, and maybe contrast it to if we did it the other way around, where we put the vertices on the axis, and see what the calculations look like. So again, I placed my square on here like we did in the homework. So 0, 0, A, 0, 0, A, and AA. And I want to show the diagonals are perpendicular. So I want to find the slope of this segment and compare it to the slope of this segment. So this first slope should be what? Y2 minus Y1 over X2 minus X1. Which is 1. I'm going to leave it as 1 over 1 because it's the slope. The second diagonal has slope y2 minus y1 over x2 minus x1. Which is the following, minus 1 over 1. Are these two segments perpendicular? Are these opposite reciprocals? This certainly is flipped, and one's negative, one's positive. So my conclusion then is, since the diagonals have opposite reciprocal slopes, they are perpendicular. Done. End of proof. Again, you could have rotated this, but then what will the slopes work out to be? 0 and undefined, which is fine. Just have to note that. Okay. Okay. I'm gonna set. I know we do. I'm gonna draw these two figures, and maybe you can figure out how to set them up on your own.
For homework?
How about the isosceles trapezoid? Let's draw the one that I had. What was the other one?
The one that was diagonal.
Yep. Unfortunately, that one that one's a specific case of one. So although there are more zeros, you're right. It doesn't give us any particular. It doesn't give us any particular isosceles trapezoid, unfortunately.
What does the bottom left
Negative a comma 0. That's a huge comma. Congruent. What's our formula? We'll come back to this one. Midpoint formula, but you also have to use distance as well. The last one.